Today, as we learn about angle relationships, you're going to see how geometry and algebra intertwine. So I'm going to give you 4 separate example problems, and then you're going to use those to solve your practice problems. I suggest that you copy the examples down on the back of your angle relationships notes. The first example that we have here asks us to solve for x and then find all the missing angle measures. Before we start a problem, you always need to draw the diagram, so go ahead and pause the video and do so. Then, the next step in solving problems like this is always to look at the information that we're given. I know that these are parallel lines, not because they look like they're parallel, but because there are 2 additional arrows on those lines, which is the symbol in geometry for parallel lines. The transversal, the line cutting through the parallel lines, I made red so that you could easily see it. When we have parallel lines cut by a transversal, we know that there are specific angle relationships that tell us when things are supplementary or congruent. So first I'm going to look at what I need to solve for, which is x. So the angles that I have that include x are this angle and this angle. When I look at those 2 angles, I need to figure out what their relationship is. I know that right now they are inside my parallel lines. So I'm going to actually highlight the inside part of these parallel lines, which tells me that since the angles are inside, that they must be some type of interior angles. When I look at the transversal, I see that one of those angles is above my transversal and the other angle is below the transversal. That tells me that these are alternate interior angles because they are inside the parallel lines but on opposite sides, alternate, of the transversal. So I'm going to go ahead and write that down, as you should be as well. Alternate interior angles. You can feel free to abbreviate angles with the angle symbol. What do we know about alternate interior angles? If you look back at your notes, we know that alternate interior angles have to be congruent. That's the symbol for congruency. So I'm going to go ahead and put 1 arc on that angle and 1 arc on that angle because I know that they are congruent. Since they are congruent, I'm going to use my algebra and set the 2 angles equal to each other. So I know that 89 plus x has to equal 80 plus 10x. I know you all can solve this. Combine your like terms by putting the variables on the same side. And then get your constants on the same side. Subtraction property of equality. 9 equals 9x. Divide by 9 on both sides. X equals 1. So I figured out what x equals, and I'm going to go ahead and write that down, but I did not yet calculate what the angle measures are. I need to actually substitute that x value back into those angle measures to find the exact angle measure. So I really have 89 plus x actually equals 1. And then I'm going to go ahead and say that that equals 90 degrees. Same thing for my other angle. I have 80 plus 10 times my x value of 1, which simplifies to 80 plus 10, which equals 90 degrees again. So I know that both of those angles are 90, and that proved that they are congruent. Now, this is when it gets fun, because once you find 1 or 2 of the angles, you can almost find all the rest of them super quickly. So first off, I know that these angles here that I'm going to highlight in orange are vertical angles. So whatever one angle is, its opposite angle has to be congruent. So opposite of the angle I calculated, this will also have to be 90 degrees. But I knew that because this box right here means that it was a 90-degree angle. Same thing applies up above. Opposite of what I calculated here is angle C. So since these are vertical angles, opposite angles, they both have to be 90 degrees. So angle C equals 90 degrees. I already have 4 of them done. How am I going to find the other 4? This is when I know that a straight line or a straight angle right here makes up 180 degrees. So if angle C is 90 degrees, angle B must be 180 minus 90 degrees, which is 90 degrees. So if B is 90 degrees, it's a vertical angle. Its opposite angle also has to be 90 degrees. And I know that there is also an angle relationship between, I know it's getting crazy here, between B and D. If you just look at the two sets of intersecting lines, B and D are in the exact same spot. They're in the top of both of those intersecting lines, which means they are corresponding, and corresponding angles are also congruent. So if B is 90 degrees, D is 90 degrees. And if A is 90 degrees, the corresponding angle to A is angle E. So if A is 90 degrees, E has to be 90 degrees. So I've basically calculated that every single one of these angles is 90 degrees. Will it always happen like that? No. But in this case, it did, because once you have one right angle and parallel lines with a transversal, they're all going to be 90 degrees.